when you're solving something and you have your variable up in the exponent position. And so somehow you need to get that to come down so it's not in the exponent position anymore in order to be able to solve it. So what do we do? What's our strategy? So this is kind of our little strategic plan over here. And again, we'll do the logarithmic examples tomorrow. So the first thing we want to do is we want to isolate the expression on one side. And what they mean by the expression is they mean specifically the part that has an exponent. So you're isolating it so it's by itself, whatever term it is that has the variable in the exponent. Then you're going to take the logarithm of each side. That helps to bring the exponent down so it's not up as an exponent anymore. And then from there you solve. And how you solve depends on what type of problem it is. So each problem is going to be a little bit different, so you have to treat them individually. So let's say this is our first problem, because, well, it is our first problem. 3 to the x plus 2 equals 7. So again, thinking back to that strategy, do you see how 3 to the x plus 2 is like isolated? Like there's nothing else over here being like multiplied or added or anything else. So that's as isolated as it can be. This is what we're looking for, is we have one term raised to a power. And that's what we got. Perfect. Now we're going to take the log of each side to help bring the exponent down, because we're going to use one of those rules that we got in 4.4. Now, because not all of us have new software, I'm going to use log to the base 10, because why would I try to put myself through like change of base and other stuff if I don't have to? So I'm going to use base 10 all day long today for the most part, unless it's helpful to use natural log. Like if I encounter some e's, I might switch, but otherwise I'm going to use log to the base 10. So log to the base 10 of 3 to the x plus 2 equals log to the base 10 of 7. Now, it seems kind of weird and illegal, like can you really take the log of each side? Yes, as long as you do it to both sides with the same base. Remember that an equation is like a balance. So anything we do to one side, we have to keep it balanced and do to the other, since the two sides are equal to each other. Okay, think back for a second to our lesson from 4.4. Where could I take this exponent and move it based on those properties? Out front. So let's do that. Do you see how that helps us and it gets us down out of the exponent spot? So now I've got this. And remember, you can write the base 10 in there if you like. I'm just not, but you can. Alright, so now we're trying to get x alone. We're trying to solve for it. So the first thing I'm going to do is divide away this log to the base 10 of 3. So this cancels. I'm left with x plus 2 equals, and I've got to figure out what this mess is. And that's why my calculator is helpful. So on my calculator, I'm going to hit log 7, close the parenthesis because we just want to take the log of 7, divided by log 3. So it's 1.77. So that whole mess of stuff that looks super intense is really just 1.77. How would you finish solving from here? Subtract the 2. So x equals, and I've got, it's going to be negative 2.3. 0.23. I just realized that. I'm like, my decimal is not moving. 0.23. Alright, now, you can double check your work with these, like you can double check your work with anything. Remember that when you're plugging something into an exponent spot, it's impacting the problem so greatly that if you don't have like a nice exact answer, like we don't because we cut it off and rounded it, right? That when you go to check it, it might not be like dead on at 7, but it should be fairly close. So if I go 3 to the negative 0.23 plus 2, oh, you can't see that. There we go. if I do 3 to the negative 0.23 plus 2, we should be close to 7. Oops, no, not another plus one. So do you see how it's close, but it's not going to be like dead on? Okay, so it should be close. But you can still check your work. Oh, it said round to 4 decimal places. Well, I surely did not follow that rule. Alright, next problem. Oh well. Such as life. I like 2 places after the decimal, by the way. Please and thanks. 8e to the 2x equals 20. Okay, believe it or not, this isn't isolated. I want this to be alone. What is it being multiplied by? 8. So the first thing I'm going to do is divide away the 8. So e to the 2x equals 2.5. Now you can use any base you want. Do we want to just consistently use base 10? Do we like that? Okay, we can do that. You can use natural log here too, and it turns out to a little bit nicer number on one side, but it's not going to matter because this will be ugly on the other side. Alright, so let's take the log of each side. We'll just do base 10 every single time for consistency. Again, if you want to do natural log, though, you can, you're going to get the same answer. And we all have that as a button on our calculator too, so there's no problem doing that. What can I do with my 2x as my exponent? Bring it down and out front, right? Mobile. So 2x times log to the base 10 of e equals log to the base 10 of 2.5. Okay, now I want to start to move stuff away from x. Let's get rid of the ugly logarithm first. What should I do to both sides to get rid of it? Divide it. Again, you're looking at it and you're thinking, what's happening here? Well, we're multiplying. So what's the opposite of multiplication? It's division. So that cancels. On the left, 2x equals something. I don't know what. Let's figure it out. I need my calculator's help. Log 2.5 divide, oh, close it, divided by log e. Where's my e? Here it is. So log 2.5, close your parentheses, divided by log e. 0.916. I'm just going to go that far. If you only did 9.2, I'm fine with that too. Alright, is it completely solved? No, what do I still need to do? Divide by 2, so let's do that. Again, 2 places after the decimal is plenty for me. If you want to go further, you can, but you don't need to. Divide by 2, I get 0.46 when I round up. And again, if I'm nervous about that answer, I can go back and plug it in, and I should get fairly close. Ready for one more? Yes, we're so excited. So excited. All right, e to the 3 minus 2x equals 4. This is kind of its own, give it its own separate little area so you know where it is. All right. Is the e term as isolated as it can be? Yeah, there's nothing out front. There's nothing being added or subtracted at the end. Like this is where we're at. We can start solving. So I'm going to take log to the base 10. Again, just for consistency's sake, it's nice to do base 10. I was going to write it, but I really don't need to. Of e, and actually I'm going to do 2 steps in one. I'm going to move this down here at the same time, except it doesn't change. So I took the log of each side and I moved my exponent down all in one step. Again, the more you kind of get used to doing these, the more you can, like, oh, I can do these 2 steps in one. Might feel more comfortable doing that. Alright, what should I get rid of first? Yeah, I like to get rid of the logs first. They look confusing. Like, why is there a word embedded within the problem? That's not helpful. So I like to get rid of that first. So on my calculator, I'm going to do log 4, close it, divided by log, and I do second ln to get e, and then I just put a 1 in for my exponent. But it sounds like the e above the division will also work, and then you wouldn't need to put the 1 in. It's been working great. Alright, love it. So 1.386 is what I get. Lovely. Well, that's not finished being solved, is it? What do I need to do next? Yep, let's subtract the 3. Negative 2x equals negative 1.6137. I'm putting lots of numbers now. I'm not going to in my final answer. And then what would I do to each side? Divide by negative 2. X equals 0. I'm going to go 81 because it's 806 on my calculator. So I'm going to go 81 for that answer. And that's all we're going to do today. Like I said, when we have the gift of time, I like to separate it into 2 days. So that way you can focus on just this one type of problem tonight. So all the problems on your homework tonight are going to be solving exponential equations. Tomorrow we're going to get into the logarithmic type, and it's a different process. Again, that's why I like to separate it, because it's not the same. If they were the same process, I'd be like, oh, we do it all in one day.